Blind Man Smart Stick. The system deals with an innovative idea of blind person smart stick. The smart stick is equipped with lots of sensor, like fire sensor, obstacle detector, water sensor, LDR sensor, tilt sensor, and emergency switch. Ultrasonic sensor is used to detect the obstacle in front of the stick. If obstacle is under 15 centimeters, then Arduino will turn on the buzzer. There is a red button on the stick that can be used in case of emergency. If the blind man stuck in danger, he can press the red button. After pressing the button, buzzer will start beeping to bring the help. LDR sensor is used to detect the light intensity. If light intensity is low, then Arduino will turn on the yellow LED. If the blind person or his stick falls on the floor, then buzzer will start beeping to bring the help. Water sensor is used to sense water on the floor, to avoid the chances of slipping. Fire sensor is used to sense the fire in front of the blind person. Buzzer is used to alert the blind person using various beep frequencies. These entire sensors are connected to the Arduino. Arduino will take data input from sensors, and alert the blind man with buzzer. This is the connection diagram of our project. Ultrasonic sensor has 4 pins: VCC, ground, trigger, and echo. Echo pin is connected with pin number 10 of Arduino. Trigger pin is connected with pin number 9. VCC pin is connected with the 5-volt pin, and ground pin is connected with the ground pin of Arduino. Water sensor has 3 main pins: VCC, ground, and output. Output pin is connected with pin number 8 of Arduino. VCC pin is connected with the 5-volt pin, and ground pin is connected with the ground pin of Arduino. Fire sensor has 3 main pins: VCC, ground, and output. Output pin of fire sensor is connected with pin number 7 of Arduino. VCC pin is connected with the 5-volt pin, and ground pin is connected with the ground pin of Arduino. Red wire of the switch is connected with the 5-volt pin of Arduino. Black wire is connected with the ground pin. Brown wire of switch is connected with pin number 6 of Arduino. Buzzer has 2 terminals. We have connected the positive terminal of buzzer with Arduino's pin number 5. Negative terminal of the buzzer is connected to the ground pin of Arduino. Yellow LED has 2 pins, positive and negative. Positive pin of LED is connected at pin number 4 of Arduino. Negative pin is connected with the ground terminal of Arduino. Tilt sensor ATXL335 has 4 main pins: VCC, ground, X out, and Y out. X out pin is connected with pin 0 of Arduino. VCC pin is connected with the 5-volt pin, and ground pin is connected with the ground pin of Arduino. LDR sensor has 3 wires: red, black, and yellow. Red wire of the LDR sensor is connected with the 5-volt pin of Arduino. Black wire is connected with the ground pin. Yellow wire of LDR sensor is connected with pin A1 of Arduino. This is the code of our project. We have connected the trigger pin of ultrasonic sensor at pin number 9 of Arduino. We have connected the echo pin of ultrasonic sensor at pin number 10 of Arduino. Now we have declared 2 variables: duration and distance. These variables will store the output reading of the ultrasonic sensor. LED is connected at pin number 4 of Arduino. Buzzer is connected at pin number 5 of Arduino. Switch is connected at pin number 6 of Arduino. Fire sensor is connected at pin number 7 of Arduino. Water sensor is connected at pin number 8 of Arduino. Output pin of tilt sensor ADXL335 is connected at pin A0 of Arduino. LDR sensor is connected at pin A1 of Arduino. XADC value, LDR value, and sensor state are 3 integer type variables. XADC value will store the data received from tilt sensor. LDR value will store the data received from LDR sensor, and sensor state will store the data received from other sensors. Void setup is a function in which we define which pin we want to use as an input pin and which pin to use as an output pin. In this project, we will give high or low signals to the trigger pin of ultrasonic sensor connected at pin number 9 of Arduino. So we will make pin number 9 an output pin. We will read the status of echo pin of sensor connected at pin number 10 of Arduino. So we will make pin number 10 an input pin. We will give high or low signals to the buzzer and LED connected at pin number 4 and 5 of Arduino. So we will make pin number 4 and 5 an output pin. We will read the status of pins at which switch, fire sensor, and water sensor are connected. So we will make pin number 6, 7, and 8 input pin. Void loop. This function will run over and over again forever. So whatever we have written inside it will repeat forever. Now we will give a 10 microseconds high to low pulse at the trigger pin of sensor. This pulse will transmit the sound waves in the environment. For doing this, we will first make the trigger pin low, then we will wait for 2 microseconds. Now we will make the trigger pin high and wait for 10 microseconds. Then we will make the trigger pin low. Now we will read the status of the echo pin. When the reflected sound waves will received by the sensor, then sensor will give a high signal at its echo pin. This function will calculate the time duration between transmitted and received sound wave. As we know that the speed of sound is approx 340 meter per second. By using this speed and time, we can calculate the distance between sensor and the reflecting object. In this project, the sound waves are reflecting from the object. If the distance between sensor and the object is less than 15 centimeters, then Arduino will turn on the buzzer. Sensor state equal digital read fire sensor pin. This function will read the status of fire sensor pin and store its value in a variable sensor state. If sensor state value is high, then Arduino will give a high signal at its pin number 5. And buzzer will turn on. It shows that there is fire in front of the stick. Sensor state equal digital read water sensor pin. This function will read the status of water sensor pin and store its value in a variable sensor state. If sensor state value is low, then Arduino will give a high signal at its pin number 5. And buzzer will turn on. It shows that there is water on the floor. Sensor state equal digital read switch pin. This function will read the status of switch pin and store its value in a variable sensor state. If sensor state value is high, then Arduino will turn on buzzer. It shows that blind man needs the help. XADC value equal to analog read X out. It will read the value of tilt sensor pin connected at A0 pin of Arduino and store in the variable XADC value. If XADC value is less than 280 or higher than 350, it means stick has fallen down on the floor. So Arduino will give a high signal at pin number 5 and buzzer will turn on. LDR value equal to analog read LDR. It will read the value of LDR sensor pin connected at A1 pin of Arduino and store in the variable LDR value. If LDR value is less than 100, it means light intensity is low. So Arduino will give a high signal at pin number 4 and yellow LED will turn on, otherwise LED will remain off. Now, we will write a code on this software. After writing the code, we will save our project. Now we will compile our code. For doing this, press this check button. If there is any error in the code, or the code is incorrect, it can be seen on the message screen below. If the code is correct, we can upload it to our Arduino hardware board. For this, we will first connect the Arduino board to the USB port of our computer. Now we will go to the Tools menu and select Arduino Uno. Then, we will go to the port option and select the port at which Arduino is connected. Now, to transfer this code to our hardware, we will press this arrow button. Now we will assemble our hardware. Connect the red wire of ultrasonic sensor with the 5-volt pin, black wire with the ground pin, yellow wire with pin number 9, and green wire at pin number 10 of Arduino. Connect the black wire of buzzer with the ground pin and red wire with pin number 5 of Arduino. Connect the black wire of LED with the ground pin and yellow wire with pin number 4 of Arduino. Connect the black wire of switch with the ground pin, red wire of switch with 5-volt pin, and brown wire with pin number 6 of Arduino. Connect the black wire of LDR sensor with the ground pin, red wire with 5-volt pin, and yellow wire with pin A1 of Arduino. Connect the black wire of fire sensor with the ground pin, red wire with 5-volt pin, and purple wire with pin 7 of Arduino. Connect the black wire of water sensor with the ground pin, red wire with 5-volt pin, and blue wire with pin 8 of Arduino. Connect the black wire of tilt sensor with the ground pin, red wire with 5-volt pin, and orange wire with pin A0 of Arduino. Now we will power up our project and test its functionality. We will put our hand in front of the sensor. If the distance between hand and ultrasonic sensor is less than 15 centimeters, then buzzer will turn on. Now if we press the emergency button, then buzzer will start beeping to call the help. Now we will put a cap on the LDR sensor to decrease the light fallen on it. When sensor will detect the low light, then it will turn on the yellow LED. Now we will tilt the stick. If stick will cross a certain limit of tilt, then buzzer will turn on. Now we will put some water on the water sensor. When sensor will sense the water, then buzzer will start beeping. Now we will use a matchstick to generate the fire. When there is a fire in front of the sensor, then buzzer starts beeping. When there is no fire in front of the sensor, then buzzer kept silent. Our project is performing as expected. We hope you enjoyed the video and learned something from it. For any help in your project or to clear your doubts, you can contact us on our student care number 7007957715. To purchase the items used in the video, you can visit our website www.erolltech.com. You can order us on our WhatsApp number also. Thank you so much.